Okay, so we only have 2 lessons left in this chapter today, tomorrow, 3A and B. All we'll do Wednesday is review the identities and stuff we had from before, and then Friday we have a test, and then next week we start with chapter 7. So, no. Chapter 7, and then chapter 9.
Are we done?
Mm-hmm.
When will we be done with chapter 9?
Are we done with chapter 9?
Yeah.
The week before finals? Yeah. All right, here we go. So speaking of distributing, you just had distributing on your quiz. So speaking of that, let's talk about when it is the right time to distribute the right way and when it's not. So the first problem I have written there would be an appropriately correct time to distribute. And then you distribute and you replace and you reduce. That is appropriate. That knowledge makes people, sometimes you hear the expression like they know just enough to be dangerous. It's like, you know a little bit, but then you make wrong decisions or wrong choices based on that. So that's what happens in the second problem, is people go, oh, I just distributed in a problem that was similar to that. I must be able to distribute here. And they proceed to distribute, which is not the right option here. So I want you to look really carefully. Why is it okay to distribute the first problem, the sign X out front? And what is different about the second one? And so would that maybe be the reason why you can't distribute it? Can you see the difference? Yes. Look very carefully. Okay, who notices a difference? Okay, Destiny.
The second one doesn't have the sign and the X. It's just sign and X separate.
Okay, the second one does not have an X. All right, that is exactly the reason. Where's the X? All right, that is intentional. Because the X is not there, that means distributing is not appropriate for this situation. You can't distribute without a variable. If you don't have a variable, you can't distribute. So this is not an option for distributing. And so what we need is we need another formula that would allow us to actually do this question. So let me teach you what the right way to do it. So you got to be on the lookout. Is there a variable or not? If there is a variable, go ahead and distribute. You can't distribute a word. Okay, sign is a word. Sign X has the variable on it. So what do we do instead? All right, sign X plus Y. Go ahead and write sine and a little space and a cosine and a little space and a cosine and a little space and a sine. And then repeat after me. Sine, cosine, cosine, sine.
Sine, cosine, cosine, sine.
Good. Okay. All right. Sine, cosine, cosine, sine. All right. Then what you do is you fill in the variables x and y in order. X and y and x and y. Come on. Go away. Yeah.
Oh, isn't this like the...
Yeah. Okay. All right, and then you put a plus sign in the center. This is the formula that you need instead of distributing. Sine, cosine, cosine, sine. It's a different formula if you're working with cosine on the outside. So here's the second. All right, cosine, x plus y. And again, you're like, not distributing. Okay, not distributing. This one starts with cosine. Oops. Oh, it's not. Yeah, we wish. We wish it would just be cosine, sine, sine, cosine, but that would be the exact same thing because it would be different. All right, so the cosine one actually goes cosine, cosine, and then sine, sine. So it starts with a double cosine.
And is it X?
All right. So again, let's kind of go through the order. So the first one is sine, cosine, cosine, sine.
Sine, cosine, cosine, sine.
Second one, cosine, cosine, sine, sine, sine.
Cosine, cosine, sine, sine.
Okay, I'm going to underline it while we say it. Ready? Okay. You guys are so smart. All right, ready? So sine, say it with me. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. And then you guys are noticing that there's an extra sign. So where is that? Okay. It's actually, what do you call that in English, where words sound the same but are spelled different? homophones, something like that.
Oh.
Okay. Okay, we're actually doing SIGN, not sign as in the trig, but SIGN. That's the third one, and that means that this is the subtraction. Okay, the sign is different. The sign changes from a plus problem to a minus problem. That's where the extra little sign comes from. And the order of the variables is still the same, x, y, x, y. All right, so we just have to practice kind of saying it in rhythm till you get it memorized in your head. All right, so we'll try again. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And you just keep doing, exactly. So I tried a little experiment this morning. My first period class came in. They learned this last year. They sat down, we did devotions, announcements, and then I just said, out of the blue, sine, cosine, cosine, sine. And on cue, they all replied, cosine, cosine, sine, sine, sine. All right, this is called the law of sums and differences. So it's just a little, and you'll do it during your quiz. You're taking your test on Friday, and there'll be sine, cosine, cosine. All right, so these are the formulas you need. Now, what if it's this? Sine x minus y and cos x minus y. Don't worry about it. It doesn't change anything about the cheer. Okay, it still goes in order. So we'll just do it. Ready? Sine, cosine, cosine, sine. Next one. Cosine, cosine, sine, sine. And then I get to my last one. And what do you think happens? Okay, so cosine, cosine, sine, sine, and then I still have the rule for SIGN, which means what happens in the center of that one? It changes to a plus instead of a minus. Okay, so only in the second one does it change. For the other one, for sine, for the top row, because it's a minus problem, it stays a minus problem. But in the cosine row, when it's a minus, it changes to a plus. When it's a plus, it changes to a minus. So that's the only one that would have that extra SIGN to represent the sign change. So we are representing the sign change from plus to minus or from minus to plus. Okay, those are the rules. Okay, we call it the cheer. So from now on, I go, oh, just use the cheer. And or the chant, or whatever. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And there's motion. There's motions. Ready?
Do we get extra credit
Okay.
for bringing pom-poms and do it?
Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay?
Do it. Douglas wants to try it. Douglas, come on. Let's do it.
All right, so it's the cheer. All right, let's do some problems with the cheer. Okay? All right, here we go.
Extra credit.
Oh, straight out? All right, so let's try. So we've got the sine of pi fourths plus 2/3 pi. All right, and again, you say, is this distributing or is it not distributing? So no variable means not distributing, which means I need to use the first line of the cheer. And so I would go ahead in my head, sine, cosine, cosine, sine. Okay? Just the first line is all you need, because this is only a sign problem. And then you go back and fill in the x's and the y's, which this time are pi fourths and 2 pi thirds, and pi fourths and 2 pi thirds. Don't change the order. Keep the order consistent. And this is a plus problem because it was a plus problem. Stay as a plus when you're in the first line of the cheer. Now we get to go back to our unit circle.
Oh, no.
Oh, you thought. You were like, I was with you, Piper, until you said we had to go to the unit circle. All right.
This is all the same chapter.
It's all connected. So I need two places on the unit circle. I need pi fourths, and I need 2 pi thirds. So pi fourths is here, and 2 pi thirds is in quadrant 2. So I've got those two. Okay, hopefully you pull out your green paper that you've saved, or you have them still in your mind, that you know what the answers to these places are around the unit circle. So we start with the sign at pi fourths, which we remember to be rad 2 over 2. Next to that is the cosine at 2 thirds, which is now in quadrant 2. Okay, remember that one?
Oh, would that be
I heard it. Negative 1 over 2. These are multiplied together. Plus, so we're not changing our plus sign. Now we go to cosine of pi fourths, which is also rad 2 over 2. Then followed by the sine of 2 pi thirds, which is rad 3 over 2. All right, so I combine them. I've got negative rad 2 over what denominator? These are multiplied, so 4. Okay, the next part, multiplied, so rad what? 6 over what denominator? Okay, what do we call those denominators? Common. Does that mean I can combine the numerators? Please say no, you can't combine radicals. Okay, you can't combine radicals. So you can do this. You can say negative rad 2 plus rad 6 next to each other over a common denominator 4, but you can't put those radicals together, okay, because somebody might think that's fake math, right? Somebody might think negative rad 2 and a positive rad 6, if they were adding them, they might think, oh, that's probably rad 4, because a negative rad 2 and a positive rad 6. And then rad 4 is probably 2, and then I can simplify, and then you're like way down the beaten track of something that you're not supposed to do. All right? Okay, questions on that one?
Is that it?
That's a sample problem. It's our first sample problem. Yes. No, I cannot reduce that any further. Your answers are all going to look like this. They're going to have rad 2s and rad 6s and 4s, lots of them. Yeah. All right, let's try another one. All right, how about we do the cosine of the same set of numbers? Okay, but we don't get the same answer. Okay, no distributing because there's no variables. And so you chant in your head the second line of the cheer, which would be cosine, cosine, sine, sine. And then you remember to go back and change it to a subtraction problem for the last sign change. So cosine, cosine, sine, sine, sine. So you remember to go back and make that change. You fill in the x's and the y's, so pi fourths and 2 pi thirds, and pi fourths and 2 pi thirds. And you go back to your unit circle, and you pull these numbers back up again. It's all coming together.
So cool how math works.
Just geek out on that a little bit for you. All right, so cosine of pi fourths is rad 2 over 2. Cosine of 2 thirds is negative 1 over rad 2. Minus the sine of pi fourths is rad 2 over 2. And the sine of 2 pi thirds is rad 3 over 2. So we have a very similar result. We get negative rad 2 over the number 4 minus rad 6 over the number 4, which the best you can do is negative rad 2 minus rad 6 over 4. But you can't combine those radicals any further. You can get a common denominator, but you can't combine. All right, any questions on the first two examples? All right. It's in degrees also, which is how we started this semester. Back in January, we learned at the first day about degrees. So cosine of 30 minus 45 in degrees. Okay, so again, you're going, all right, there's no distributing. This is the cheer. It's the second line of the cheer, so this is the cosine, cosine, sine, sine, sine part. So cosine, cosine, sine, sine, and then I go back and I remember to do what in the middle? It is now a plus because it was a minus, so it is a sign change. And then we fill in our x's and y's, which are 30 and 45, and 30 and 45. And we should hopefully remember where those are on the unit circle. 45 is still the same place, 45 degrees. 30 is the same as what radian? 1/6. Good. So we're dealing with those two. We're dealing with pi fourths and pi sixths. And so we'll pull out those values. The cosine at 30 degrees is rad 3 over 2 multiplied by rad 2 over 2. Plus, the sine at 30 degrees was half, and rad 2 over 2. So again, you see the answers always are strikingly similar, just in a different order with different amounts of pluses and minuses in it. So rad 6 plus rad 2 over 4. So you'll find your answers tend to start looking the same. All right, so degrees helps you be able to do the following. What if you're asked a single number? Okay, if all you're asked is 75. Okay, so 75 is not on the unit circle anywhere. So your job is to replace the number 75 with an addition or a subtraction problem that works in degrees to work out to be 75. Okay, so there are multiple ones that will all work and get you to the same answer. So someone I heard say 45 plus 30. That would be totally legitimate, and they would do sine or cosine, cosine, sine, sine, sine to that. Someone else might have thought of something different. Maybe someone else thought of 135 minus 60. Okay, it can be any addition or subtraction problem that works out in degrees to equal 75. Someone else might have thought of that. And they would have done cosine, cosine, sine, sine, sine to that one and still got the right answer. It's any combination of degrees that we work with. So the degrees that are legitimate to work with. Work with 30. What else? After 30, just think around your unit circle. What are legitimate and what? 45? What next? 60. What next? 90. Sure. What next? 120. Can't skip that. Then 135. Then 150. And then finally 180. Okay, those are legitimate ones to work with. So any combination of adding or subtracting, so you could do it different from someone else, you'd still get the same final result. So you would do cosine, cosine, sine, sine, and then remember to change that to a minus. Where's she going? No, she's not canteen. Tessa's canteen. Okay. All right, or cosine, cosine, sine, sine, and then remember to change that one to a plus. Either one of those is legitimate. Both of them will work. Both of them will end up with the same result for your answer. Okay, so you kind of have the power to fix some of those in degrees. It works that way for radians as well. I'm not going to finish this one, but hopefully you get the idea that we would fill in 45 and 30. 45 and 30, please don't change the answers. Or here you'd fill in 135 and 60. And 135 and 60. Please don't change the order of how those are going to go. All right, the last thing I want to last two things I want to show you. Okay. What about doing something in radian, like something on a 12?
Don't you have to subtract by like 2 pi's?
Okay.
It has the 12 on the bottom.
Okay. So what happens here is that 12 is not on our unit circle. What fractions are on our unit circle? 6s. What else? Fourths, thirds, halves, not 12s. Okay, 12s are not on our unit circle. So what you need to do is come up with a way to add up to get to 12. So 2 12s, and how many other 12s? Would be 5. 3 12s. Okay, good. 2 and 3 is 5. Okay. So you replace it with an addition that works out. Okay, it has to be an addition that works out to be 12. Could you have used a subtraction to work out to be 12?
Yes.
Sure. Okay, so suppose you used a subtraction. Suppose you did 9 12s. And I said, well then, okay, what would the subtraction be? To make it be 5, 4. Okay, that works out to be 9 minus 4 is 5. Okay, why am I picking these numbers? Because reducing them gets me back on the unit circle. So if I reduced this one, it's just pi over 6. And if I reduce this one, it's pi over 4. And if I reduce this one, it's 3 pi over 4. If I reduce this one, it's pi over 3. Now I'm back on the unit circle again. So any one of those is going to work too. Okay, any one of those will work. And you just use the sign cheer, which is sine, cosine, cosine, sine, with no changing in the middle. If it's a plus, if you used the plus one, then keep it plus. If you used the minus, keep it minus. So if you're working with 12s, you just got to find ways to add up some 12s to either add or subtract to make that number. Practice a minute. What would you do if it was 11 12s? Give me an example of how you would replace that with a couple other 12s that would work out. What could you use to make 11?
Oh, you can't just do 13. Oh, we have to make it equal to 11?
Yeah, gotta make it be, so that's fine. You wanna do 13?
I'll
But
just do
13 12s is not on the unit circle, so
Yeah,
that's no good.
I was gonna do subtraction by one.
Okay,
I'm sorry.
that's okay. Anybody else? Idea to make 12s.
Yes.
How about 8 and? These are just fractions. 8 and what? 8 and 3.
Would you be able to split it up into 3?
No, 2. Okay. Why is that good? Because 8 12s reduces and 3 12s reduces. Okay, final example. Anyway, do you want me to finish one of these? We have time. Okay, so if I finish this, if I do 8 12s, that reduces to 2/3. And 3 12s reduces to 1/4. So I will use the sine part of the cheer, which is the first line of the cheer. Sine, cosine, cosine, sine. We fill it in with 2/3 and 1/4 and 2/3 and 1/4, which I think I already did. This is a plus problem.
So the sign only switches when it's cosine, right? Then it's
Correct.
negative.
The SIGN
Yes.
only changes, there's only a sign change
When it's cosine.
for the cosine part of it. And so then this would work out to be rad 3 over 2, rad 2 over 2, plus negative 1/2, and rad 2 over 2, which ultimately works out to be rad 6 minus rad 2 over 4. All right, last thing. What's the pattern in math? If I teach you something and you work on it and you practice it, then what do we usually do a couple days later? We,
Take a quiz.
well, usually before that, we learn to do it backwards,
Oh,
right? When you learned squares and then you learned, what's the backwards of squares? Square roots. You learned trig and then you learned inverse trig. You learned addition and then you learned subtraction. You always do math first and then, all right, so let's do it backwards. Let's suppose someone else has already expanded it for you. So suppose it looks like this. Cosine, cosine, sine, sine, sine. So it's already been expanded, and it's filled in with 50 and 13 and 50 and 13. So someone else has already done the work. Can you put it back? Can you put the pieces back to where it came from? So which line of the cheer is this coming from? This is coming from cosine. What always happens in the cosine part of a cheer? The sign changes. So this would be a plus problem. And what two things would be the x and the y that are added together? 50 and 13. And so this came from somebody who was splitting up 63. Could they have split 63 up differently?
Yeah, they can.
For sure. Okay, they could have done, 47 and 16 or 62 and 1 or whatever. Okay? They're not quite endless, but they are various for sure.